On the second formative assessment, our first problem was about multiplying rational expressions. We had to multiply these two rational expressions and then reduce to lowest terms. And then we're also asked to determine the values of x that cause the original expression to be undefined. So let's start by working on this product. So at first glance, we may imagine just taking this 3x and multiplying by each of these three terms in this quadratic, and then multiplying the two binomials on the bottoms of these expressions in order to get a quadratic out. But that actually moves us away from the factored form of this product. And remember, we want to factor this completely so that we can see if there are any common terms on the top and the bottom that divide out. So first of all, I'm going to take a look at this piece right here, and I can see that it is a quadratic, and it's actually pretty easy to factor. I could just write x plus 5 times x minus 2. So I hope that you're pretty comfortable factoring quadratic expressions like this one. There are techniques for doing that, and one of the things I will just always do when I factor something like that is I'll multiply it back out in my head to make sure that I get back to the original expression. X times x makes x squared. And a positive 5 times a negative 2 makes that negative 10. And then this 3x comes from the inside and the outside product. So we've got a positive 5x, a negative 2x, and those combine to make a positive 3x. So this product, in fact, multiplies out to make this. So I factored that thing. I can also factor the bottom. It's not a quadratic, but those two terms have a common factor, 3. So I factor that out. This first rational expression cannot be factored. It's already in its most factored form. There are two factors on top, 3 times x, and just 1 on the bottom, x minus 2. And to make it more obvious, what I'm doing here is I put the parentheses around this, and I see that if I just multiply this straight out, I would get 3x times x plus 5 times x minus 2 on the top. And then I would divide that by the product of everything on the bottom, which is 3 times x minus 2 times x minus 3. And that's what's great about multiplication, is it's commutative. I can rearrange these three terms in whatever order I want. Now that I've done the multiplication really by just writing all the factors on the top and the bottom of my product, I can look for common factors that divide out. 3 divided by 3, that's 1. So those two factors will divide out. And notice the 3 and the x, they don't necessarily come together. They're two individual factors. I can cancel out just the 3 and leave the x. There's another common factor, x minus 2, on the top and the bottom. When those divide out, I'm left with just two factors on the top and 1 on the bottom. So this becomes x times x plus 5 divided by x minus 3. And that is the simplest or lowest terms of this product. Can't make it any lower than that. And that is the first thing I'm asked to do. Multiply the following rational expressions and reduce to lowest terms. Done. Now, determine what values of x would cause the original expression to be undefined. This is the original expression up here, these two expressions being multiplied. And I have to think about all the values of x that would cause me to divide by 0. Okay? So I want to I can look here and see that if x was equal to 3 in my final expression, that would cause me to divide by 0, and thus the final expression would be undefined if x was equal to 3. Now, I have to consider the factors that I canceled out also, because those are part of the original expression. So x is not allowed to be 2, or if I should say, if x is equal to 2, then I would also be dividing by 0, and this expression would be undefined. So there's two values of x, and I can see them both here in this expression before I cancel anything. X cannot equal 2 and x cannot equal 3 because that would cause the denominator equal 0, and then I would be dividing by 0, which is undefined. So x is not equal to 2 or 3 because these values cause division by 0.